Okay, I just want to give you a quick overview of what to expect for this exam coming up on Wednesday. The exam will cover chapters 3, 4, and then the very first part of chapter 5. So, of course, chapter 3 covers, actually, we're looking at the second part of chapter 3, which is projectile motion. So maybe about a third of the exam is that. A good bulk of the exam is in chapter 4. This was on Newton's laws of motion. And then chapter 5 was on work. There will also be an extra credit question, which will be either from chapter 3 or 4. It was originally a question that I had in the test, and then when I revisited the test and thought, well, y'all can do that question, but it's a little more complicated than I'd like to have in the test. So I decided to make an extra credit question. It's not multiple choice. You have to get the right answer in order to get credit for that. All right. Now, for the work, it's going to be very limited. Just the very first part of that chapter 5. In fact, if you're looking at the homework, you really only need to do number 1 on the homework. There will be an equation sheet from chapter 5 onward, so you have that equation sheet. But the only thing really on the equation sheet is the very first one, and that is that work is equal to force times the distance times cosine of the angle theta. So for example, if I have an object and I have a force, say 10 newtons, and I have an angle, say 40 degrees, and it moves over a distance of 3 meters, then in order to find the work, I would say the work is equal to the force, that's 10 newtons, times the distance, which is 3 meters, times the cosine of the angle between them, cosine of 40 degrees, and then that would give me the answer. So you will have a problem where you just have to calculate the work. Okay, very straightforward, just calculating the work. You just do the force times the distance that it moves times the cosine of the angle between the force and the distance. And in this case, the force is in this direction. The distance vector, or the displacement vector, is in this direction. And so the angle between them is just the angle that's given as 40 degrees. So look at problem number 1 in the homework. You can look back and see some sort of similar problems in the old test. I'll also have a few conceptual problems. I think total there are 5 or 6 questions from chapter 5. A few conceptual problems. Need to realize that if I have a force in this direction and it moves in this direction, I've done positive work on that object. If I have a force in this direction and it moves in this direction, that force has done negative work. A good example of this would be friction. Now remember, I'm talking about a single force, but there could be multiple forces on an object. So if I have a force, say a tension force here, I have a frictional force here, and I have a normal force here, and I have the weight here. If I look at these forces, assuming that the object is accelerating in this direction, it must be since we have a kinetic frictional force going in that direction, then the amounts of work done by these are different. This force is doing 0 work. This force is doing negative work. This force is doing 0 work in the y direction because there's no displacement in the y direction. And then this force is doing positive work. So you need to have a good understanding of if a force is in one direction and the displacement is in that same direction, it's doing positive work. If they're in opposite directions, it's doing negative work. If they're perpendicular, then it's doing no work at all. And that comes about, by the way, from this cosine theta term. Cosine of 0 degrees equals 1. Cosine of 180 degrees equals -1. That gives me the -1 makes this negative, the positive one makes this positive. And then cosine of 90, as we see here, where my displacement is in the positive x direction and my force vectors are in the y directions, cosine of 90 or cosine of 270 are both equal to 0. So those do 0 work. So it comes out mathematically that way, but really just thinking the force is in one direction, what's the direction of my displacement? Or if there's no displacement in that direction, then my work done is 0. You also need to know little things like what are the units of work? Well, a unit is force times displacement, so that's going to be Newton meters. Or breaking down that newtons is going to be kilogram meters per second squared meters. Basic things like that, but you should know your units anyway for everything that we're doing. Okay, so that's chapter 5. Chapters 3 and 4, again, projectile motion and Newton's laws of motion. Go over the concept test, go over the homework, look at the old exams. That's how you prepare for these exams. It shouldn't be any big surprises. The only thing that'll be different on this exam is that you will have an extra credit problem, which will either be from chapter 3 or 4. You must get the correct answer in order for me to count. I will give no partial credit. All right, that's all. We will have a help session, by the way, on Monday at 3 p.m. in Beauregard 104.